Hello, and this is Regina Boland. I'm happy to present our work today at the AMIA Informatics Summit. Investigating three classification methods for per polyfluoroalkyl substances, exposure from electronic health records, and the potential for bias. This paper is a full paper, it's a 10-page paper, and it is available via the AMIA proceedings and on PubMed Central soon. And it can also be available if you email me at bolandm@upenn.edu, and I'll be happy to provide you with a copy of the manuscript as soon as possible. For our disclosures and conflicts of interest, we have no relevant financial interest to disclose, and we have no conflicts of interest. The learning objectives for today's presentation are to learn how to use EHR data effectively for environmental research studies and to reveal patterns of disparities that illustrate issues related to environmental justice. As a background, PFAS is a chemical used in firefighting foam. It has also been popularized in Teflon-coated pans. It has been linked in many studies by many different groups and individuals throughout the US and the world at this point. It has been linked to heart disease, cancer, thyroid issues, among other diseases. There is a heavily exposed area just outside of the city of Philadelphia. There are three towns called Horsham, Warminster, and Warrington in the state of Pennsylvania. They were used in a prior study conducted by our team, published in Nature Digital Medicine in 2021. In that paper, we actually successfully validated known diseases associated with PFAS exposure using electronic health record data alone. We were able to replicate many known diseases related to kidneys, thyroid, and high cholesterol. The goal of this study, which is a bit different, is to use augmented electronic health record data to classify PFAS exposure for patients that are living in New Jersey. So this differs from our prior work of patients from a heavily exposed region in Pennsylvania, and we're now going more broad and looking at patients living in New Jersey. We explored in this paper the utility of three different exposure assessment methods for classifying PFAS exposure that are popularly used in the literature, resulting in different boundary types: public water supplier service area boundary, municipality, and zip code. State regulations in New Jersey enabled us to have rich PFAS information for various water sources in the state, enabling us to assess PFAS exposure at the municipality, zip code, and public water supplier levels. Our first step we restricted our Penn Medicine cohort from over 1 million female patients to almost 172,000 female patients who lived in New Jersey. We then stratified by where they were treated in terms of inpatient or outpatient facilities. In this dataset, all of the inpatient facilities in general were in the city of Philadelphia, whereas the outpatient facilities, there were many Penn Medicine outpatient facilities in New Jersey, and therefore patients likely did not have to drive as far. They definitely did not have to pay a fee for the bridge to cross the bridge, and so forth. So we thought that logically it would make sense to stratify our cohorts in this way. We then measured the relationship between PFAS assessment method and the risk of known PFAS-associated diseases in both the inpatient cohort and the outpatient cohort. 162,000 patients were classified as non-PFAS exposed regardless of which of the methods we used. So these patients were definitely non-exposed patients. However, once we got into PFAS exposure, we ended up with almost 10,000 patients that were exposed via one of the three methods. We had 9,468 that were considered exposed using our municipality boundary, 5,890 using the PWS boundaries, and 5,833 using the zip code boundaries. We created a Venn diagram, and instead of using three circles, we used one circle for the municipality, that's the blue circle here. We then used, for the PWS, a triangle, that's yellow, shown here, and for zip code we used a rectangle in a sort of a greenish color. One of the things that's important to note is that there are 5,011 patients that are found in the intersection. These patients are PFAS exposed regardless of the method that we use. Additionally, there are 3,131 patients that are only found to be PFAS exposed using the municipality method. So these are additional patients that are pulled in as a PFAS exposed patient using municipality. We had 359 patients pulled in using only the PWS method, and then there are 0 who were PFAS exposed using only zip code. Here is a look at the demographics of the cohorts. Again, because the no PFAS was such a large cohort, and we're not exactly as interested in those. We're interested really in the PFAS exposed. So I will restrict it there, that table down to make it a little bit clearer. And then we also made a bar chart of that same exact data from that table, showing PWS, municipality, and zip code. Interestingly, more white patients are pulled in using the municipality method, and there's a little bit of a reduction of Black or African American. Again, remember that the municipality method had a lot more patients. It was pulling in an additional 3,000 patients, so there was more patients obtained in that method. And there was also a higher amount of other, unknown patients identified using that method. When you look at the non-exposed, again, there was very little variation because this cohort was so large, and there wasn't as much variability in that group. When we take the data, again, on PFAS exposure and we sort of look at it a different way, you have here the non-PFAS patients and then the PFAS patients. Something that should jump out at you immediately is that the Blacks or African Americans are much higher in the PFAS exposed versus their non-exposed. Their percentages are like less than 10% in the non-exposed, again, because this is our New Jersey patients. And then they jump up to almost 40%, like floating around, I guess, 35% in our exposed. This is a huge difference. It's almost 3.5 times the difference. Same data is shown again in a different way to kind of help make this clear. These are the non-exposed and these are the exposed. These are the non-exposed and then these are the exposed shown here. There is a much relatively higher proportion for Black or African Americans, and then there's a lower proportion among the whites when you compare white PFAS exposed to white PFAS non-exposed and Black PFAS exposed to Black non-exposed. This disproportionately high rate of Blacks or African Americans with exposure to PFAS regardless of method assessment type. So this can be found regardless of which method you use. And this represents a major environmental justice issue. We then looked at linkage with diseases. We took, again, those 4 methods. We did include the intersection as a separate method because with the idea that they would be the most exposed. So looking here, we found that it is in fact true that the intersection patients had the highest odds ratios of about 1.6 for essential hypertension. Zip code had the lowest, a little bit under 1.4, so about 1.37 or so. Municipality had the next highest, which is just under 1.6, and PWS was maybe around 1.5 or so. We were a little bit surprised that municipality performed so well, especially with that additional 3,000 patients, so it's a much larger cohort. But that was comforting, meaning that the municipality is actually pulling in meaningful patients that are likely PFAS exposed, and so that was also interesting. For people who love p-values, we did include Manhattan plots. I do want to mention that typically when one performs a Manhattan plot for disease and its relationship with something like PFAS exposure, you pick only one method. And so we had 4 exposure assessment methods here. So even though this red dashed line represents, the bound for any adjusted p-values, you wouldn't normally have 4 methods for every single disease. So this is definitely like overcorrecting. We just wanted to show you this for the sake of comparison purposes. Our goal for this work was actually to compare these different methods and see kind of how they do. So here actually, zip code had the highest p-value, but I think they ended up with one of the lowest odds ratios, and then the intersection had the second highest p-value. Generally speaking, the intersection did do fairly well in terms of the p-values, and you see that with in these different plots. So we were just kind of looking at it for relative comparison purposes. We were more concerned about the replication across method types and also the differences in the sample sizes that could be derived when we use different exposure assessment methods. Overall, we were able to successfully link PFAS exposure information with patient information using 3 different common exposure assessment methods. Our approach highlights the strengths and limitations of these different methods for capturing PFAS exposure, given the differences in cohort sizes and in some cases demographics. We did find that Blacks or African Americans experienced a greater PFAS exposure burden than whites in New Jersey, regardless of the PFAS assessment method, municipality, zip code, or PWS. We are actually very excited to share as much of our methods and experiences as possible. If you're interested in either collaborating or if you want access to some of our code or some information, have questions of any kind, please feel free to reach out bolandm@upenn.edu. We also have a GitHub account where we try to post code regularly, as well as fake patient data if you want to try to run our scripts on your data set. Again, thanks to everyone in my lab. Here's a few pictures of us before COVID, and here's a few pictures of some of my lab after COVID. And again, if you have any questions, feel free to reach out. We have a few different methods of which you could reach us. And I wanted to mention in memoriam, the first author of this paper. It's only actually a two-author paper, but the first author, Lena Davidson, passed away in early December 2022. And I, Regina Boland, would like to dedicate this presentation to her surviving husband and son. And I would also like to say a special thanks to her. You will always be remembered. And this quote from Hippocrates is something that I think she really embodied very well, which is, "Wherever the art of medicine is loved, there is also a love of humanity." And again, thank you to her, and thank you to everyone who is listening to our presentation. And if you have any questions at all about our work, please feel free to reach out. Thank you again.